Oklahoma City Public Schools Technology Engineering. Since 1985, we've been the original science, technology, engineering, and math curriculum. For more than 30 years, we've been inspiring thousands of students to have a passion for the design process, making things, and exploring high-demand, high-paying STEM careers. Our technology engineering students explore self-paced, hands-on technology modules. They unleash their creativity by applying the design process. Our students learn STEM content, calculate design-related math, communicate their designs, and maintain engineering journals. Students quantify their learning with posted learning targets and rubrics. Each week, the students explore STEM careers related to their modules. A technology engineering semester will include career portfolios, virtual job shadowing, and group design projects. In the manufacturing technology module, our students create wood projects with a scroll saw and a sander. Students use templates and create unique designs of their own. Shop safety is practiced as they learn to create neat cuts and sand their projects smooth. Students learn how to use wood glue, and they finish their projects by spray painting them. The 3D printing module teaches the students the language of design. They use traditional 3D computer-aided drafting to design custom decorated ink pens and rings. They learn the CAD functions of line, arc, trim, revolve, tube, and join. Students apply file management and 3D printer slicing software. In addition to traditional CAD, our students are using a new innovative design tool. Using virtual reality, our students enter an empty room where they model design solutions in virtual clay. With hand controllers, the students are able to naturally stretch, extrude, scale, mirror, lathe, and modify their designs. Each student is given a budget of filament. They calculate the cost per meter and adjust the size of their prints to stay in budget. 3D printing is an effective platform for students to bring their ideas to reality. Using both the traditional CAD and virtual modeling, our students keep the 3D printers running non-stop. At the rubber band-powered airplane module, the students build and fly a model airplane kit. This gives the students practice at following complex assembly instructions. A successful plane has multiple parts that have to be assembled in order. The students have to neatly glue and then cut out each part. Often, the most overlooked step in the design process is testing and improving the product. Students get to apply this step by repeatedly making minor adjustments until their planes fly straight and level. Our electricity module gives students the opportunity to explore electricity fundamentals and use basic electronics components. Students understand the functions of resistors, capacitors, diodes, batteries, and integrated circuits. There are 300 projects to build, including flashlights, alarms, games, transmitters, and AM radios. In aerospace design, students compete in an aircraft design challenge. The challenge is to build the fastest airplane that weighs under a specified weight. To compete, the students have to understand the forces of flight, aircraft parts, center of mass, and center of lift. An exceptional or record-breaking design gets 3D printed as a trophy for its creator. Roller coaster design gives the twin challenges of creating a popular theme park and designing a unique roller coaster. Students create the theme park within specified design constraints and test and modify it to meet certain criteria. Students then design a roller coaster. Students discover basic coaster physics and modify their coaster until it functions correctly. The reward is to ride their creation. In structural engineering, students design, build, and test model bridges. While following video tutorials, students learn bridge design basics, including the use of triangles. After the design process is complete, the students build their bridges with 1/8" basswood and hot glue. Students take care to cut joining angles accurately. They use just the right amount of glue for strength, but not too much to add excess weight. The bridges are tested by stacking blocks of wood on top until they break. A long-standing record is all 68 blocks you see on the table. Students then calculate the efficiency of their bridge by dividing how much weight it held by the weight of the bridge. Our coding and robotics module addresses one of the most critical skills gaps in the American labor market. Students pursuing careers in coding and robotics will have endless opportunities in our automation revolution. Our students build a custom maze and then program a Lego robot to go through it. Students control the movement of the robot by programming its servos to rotate a specified number of degrees at a certain speed and direction. The students also program the robot to respond to input from touch, light, sound, and distance sensors. The problem-solving module gives students repetitive practice at the problem-solving method. Students apply brainstorming, idea selection, and testing. While solving the puzzles, students discover how to use inclined planes, gears, pulleys, levers, wedges, and wheels. In laser manufacturing, our students get 6 days of one-to-one use of a laser cutter. The students learn graphic design basics. Students use CorelDRAW software to design and manufacture their products. Students open templates, import image files, align design elements, and design custom shapes. Students differentiate between raster and vector elements. With experience, the students can tell which images have sufficient contrast to engrave well. The students are able to manage print drivers, determine material size, select the correct material, and glue their projects together. The Architectural Design module gives our students experience with Chief Architect design software. The design challenge is to create a home sized between 2,500 and 3,500 square feet. The home has to have a logical layout and all the rooms have to be aesthetically pleasing. Students work through the process of rendering design photos, placing them into a layout as though they are presenting it to a client. When all the design criteria are met, they print the blueprint. On the CNC manufacturing module, the students get to design, cut, and paint signs. After they master the Cartesian coordinate system, they start their designs using a CNC CAD software. The students size the project, create the outside frame, insert images and then text. They align the design pieces and then calculate the toolpath for the machine. The students transfer the G-code to the CNC router, clamp in the material, and watch it carve. The students take their carved sign to the paint table. The signs are painted and then cleaned for the finished product. Occasionally, some of our Technology Student Association students choose to create a project to compete at the state conference. They've created beautiful pieces such as unique bowls, cars, 3D relief signs, CO2 dragsters, Antarctica scenes, and jewelry boxes. The students start their experience on the welding module by mastering a virtual welder. They then run practice beads on a billet until their welds are consistently straight and of correct width. They use a CAD software to create a unique nameplate design. They draw, insert text, trim, and then process the design for use on the CNC plasma cutter. The plasma cutter cuts out their design, and they knock the dross off the back of their pieces. They position the pieces with magnets and weld it together. The projects are finished with 2 coats of paint. For enrichment time, we have 3,500 blocks made from melamine. They are twice as wide as they are thick and twice as long as they are wide. The students can build any structure that they can imagine. Through the years, we've had many towers and many unique castles. Periodically, our students attempt to build a successful 110-foot domino fall. The blocks don't fall well, and the students have to communicate and work together to make it work.
Okay, maybe second time in history today. It could be today. Come on, come on, come on.
There are many ways we can measure our success, but the greatest is when our students can say with pride,
I made this.
I solved this.
I made this.
I made these.
I made this. I made these.
I made this.
I made this.
I made this. I made this.
I made this. I made this. I made this. I made this.
I made this.
I made this.
I made this. I made this. I made this. And I'm proud of myself.